Welcome back to Distributed Tracing in Next.js. This is lesson 5, where we're going to implement distributed tracing in the methods responsible for the update flashcard flow. Let's jump right into it. To start with the implementation, let's open the hooks file. So source/hooks/flashcards. This is where the distributed tracing will begin. Alright, so let's start by obtaining the current scope. We can do that by const scope equals to Sentry .getCurrentHub.getScope. So let's make sure we import Sentry. Import everything as Sentry from @Sentry/Next.js. There we go. So what is the current hub and what is the scope? You can think of the current hub as like a central point that the SDK uses to route all the events to Sentry. So when we ran the wizard, it created all of these config files for us. This is where we initialize the Sentry SDK. But that's the moment where a new hub gets created, an empty scope gets created and attached to it. And you can think of the scope as like a data carrier. All of the information like the breadcrumbs, the navigation, etc. are stored on the current scope, including the transactions. So because we are going to be implementing distributed tracing that starts off with a transaction, we need to obtain the scope. Right, so since we have the scope now, we can create our first transaction. So const transaction equals Sentry.startTransaction. And we can give the name of update flashcard. After we've done that, we need to get the current scope, which could potentially be undefined, and then call the setSpan and pass the transaction. This assigns our custom transaction to the current scope. Alright, so we're set. As you know, transactions can start child spans as well. So let's actually create one. We can do the transaction.startChild. It needs two properties. It needs an operation and a description. In this case, we're going to use a mark type of operation, which is a special type of child span that is timeless. It does not measure anything. It just marks a certain point in time. And for the description, we can do equal signs, making the API request. Cool, and because this is a mark type of span, we can immediately call the finish method on it. There we go, that's how we can start child spans. Scroll down and add the Sentry trace header. So if the transaction exists, we're going to get our headers object and assign a new value to the Sentry-trace key. And that value is going to be the transaction.toTraceParent method, which will return the Sentry trace for us. Okay, and afterwards, we perform the API requests. But this time the API request actually has our Sentry trace. So it's going to hit the backend with the trace that we started on the client side. Okay, so let's proceed there. Let's go to the pages, API, flashcards, and then the slug file. Just like on the client, we're going to obtain the scope. So const scope equals Sentry.getCurrentHub.getScope. But this time, instead of creating a new transaction, we're going to obtain the transaction from the current scope. So transaction equals scope.getTransaction. So what happens here? When the backend received the HTTP request, Sentry noticed that there is a trace distributed from the client side. So it created a transaction for us and bounded it to the current scope. In order for us to proceed working with that transaction, we need to obtain the current scope and then we can obtain the transaction from the current scope. So anything we do on this transaction is going to be included in the distributed trace. So we can start creating child spans. Let's create one for the category checks. So category checks span equals transaction start child. We'll set the operation to a function this time and provide the description of category checks, because that's what we do after we try to get the category. So in this case, we can do a category check span. We can set the status to not_found and also call the finish method, because this is where we return back the result. We can also do pretty much the same for when the category does not belong to the user, but this time the status is going to be unauthenticated. Right. But if none of that happens, we can safely invoke the finish method to that span. Okay, then we obtain the flashcard, and then we do a few checks based on the flashcard. So let's create another span for the flashcard checks. So flashcard checks span equals transaction.startChild. We'll give the operation a value of function and the description flashcard checks. Cool. If there is no flashcard, we can do flashcard check span.setStatus to not found and also call the finish method on it. So if the required data is not provided, we can set the status to invalid argument, for example, which is equivalent to the HTTP 400, and also finish the span. And again, if none of this happens, we can safely invoke the finish method of the flashcard check span. Cool, so then we'll perform the update and return the result. In this case, because we didn't create the transaction, we don't actually need to finish it. The SDK itself is going to take care of that. All right, so we're going back to the client now. So after the HTTP requests, we get the result back. And if the result is okay, let's create a new mark span. So start child, the operation is mark. We can set the description to updating the cache, and then we can finish it. So this just marks the time just before we update the cache, and then we do update the cache. Then we can do another mark. So transaction.startChild. Again, the op is going to be mark, and the description is going to be finished updating the cache. There we go. Then we try to serialize the data from the response. So let's create an actual span for that. So serialized span equals transaction start child. We'll set the op to serialize, and let's set the description to serializing response. Okay, then we do the serialization, and afterwards we need to call the finish method on the serialize span, and also transaction.finish, because we're pretty much done, and we return the data. Okay, but then there's also the else case when the response is not okay, or we haven't received 200 okay. In that case, let's create a new error span. We can set the operation name to just a mark, and set the description to failed to update flashcards. Reason, and we can pass the status text. Okay, and just before we throw the error, we need to call the finish method on the error span and also finish the transaction. All right, then that's about it. Before we run the app, let's make sure that we add the Prisma integration. So let's go to the Sentry server config, and inside of the init, we can provide a value for the integrations field and pass the Sentry.integrations.prisma. We need to pass the client. So let's obtain the client, which is import Prisma client from Prisma, which is a directory at the root that exports the Prisma client from the index.ts file. Cool. We got the Prisma client. Let's pass it to the integration. And this integration automatically instruments all of our Prisma requests. We'll see it in the dashboard later. Okay, so now let's run the app again. pnpm dev and open localhost 3000. There we go. So let's try to update one of the flashcards. Let's do it 2 more times for good measure. Now we can go to the dashboard and search for the update flashcard event. We might need to give it a minute for the event to arrive and get serialized by Sentry. So I'm just going to refresh the page a few times. Okay, there we go. Here is the update flashcard transaction. Here are 2 of the events that I triggered. And if we click on the first one, we can see the whole flow of updating the flashcard. Right, so let's look at this chart right here. The whole operation took 708 milliseconds. But below the first row, we can see the whole operation broken down into multiple operations. It starts off with the making the API request mark child, which is 0 milliseconds. Then we have the put requests or the backend operation as the second action. Then we have another mark, which is the updating the cache. And when we triggered the cache mutation, the browser made the API calls for getting the what is a closure and also getting all of the flashcards in order to mutate the cache. Then at the end, we have the serializing response. But the cool thing about distributed tracing is now we can take a peek at what happened on the backend. And we can do that by pressing the plus sign here. And check this out. We do the user find unique first, and this is because of our Prisma integration. And the category find unique. Then we do the category checks, which took 0.02 milliseconds. Then we try to find the flashcard if it exists. That took 24 milliseconds. We have the flashcard checks, again, pretty fast. And then we do the actual update of the flashcard, which took around 155 milliseconds. Okay, so as we can see, when the HTTP client request finishes, that's when the updating the cache starts, and we're back at the client side. So there we go. We started a transaction on the client side, we passed it to the backend, it measured the execution for us, it passed all the data back to the client, and then we added some more data on top of it. So now we can see the whole update flashcard flow, both on the client and the backend. And that is distributed tracing. And that's it for this lesson. Don't forget to check out all the resources down in the description below. Like and subscribe, and go check out the next video in the series. Thanks for watching.